Good morning, everyone, and welcome to the Fenner School of Environment and Society. My name's Professor Catherine Daniel, and I'm one of the leadership team of the Institute for Water Futures, which is based here at the Fenner School, and also the editor of the Australasian Journal for Water Resources, under which this special issue was created. Before we begin, can we please acknowledge that we're here on Ngunnawal and Ngambri country? I would like to pay my respects to the elders past and present, and acknowledge their continuing culture, history, relationships to water, to land, to sky country, and that in terms of what we're talking about today, many of our Aboriginal populations, the 40 nations across the Murray Darling-Basin, are many of those communities who will be some of the most impacted by some of the risks that we're talking about today. And so thinking about how to include those communities in the discussions about the future of the Murray Darling-Basin is extraordinarily important. In terms of what we're looking at today, this particular special issue is about risks to shared water resources in the Murray Darling-Basin. This is a public event. The group of authors have also been having other discussions around this, and we're really delighted to be able to bring these presentations of this entire journal publication to you today, and many greetings to people online. For this particular process, for those of you who are unaware of the history, back in 2006 there was a CSIRO report that looked at these shared risks, and this particular group of authors has now been able to update each of those risks, and so we'll be thinking about what's changed over that period, what still needs to be thought about in the context of the Murray Darling-Basin. And I think part of this is to ensure that with these risks and the uncertainties, we don't necessarily postpone our thinking until we have more information. There's plenty of information out there, and now it's a matter about how we work together to think about adapting to making these decisions under uncertainty. And so with that, I think I am going to introduce Jamie Pittock, who's also going to talk about how this review was undertaken by 24 researchers from 8 universities to highlight many of these issues. So Jamie will introduce all of the teams one by one. Thank you so much.
Thank you. My name is Jamie Pittock. I am a Watery Professor of Geography at the Fenner School of Environment and Society and the ANU Institute for Water Futures. And so I will now give a brief overview on the risks to shared water in the Murray Darling-Basin project that has led to this special issue. I'll note that a wise and benevolent chief editor of the Australasian Journal of Water Resources has made the special issue open access for these few days of this seminar. So for all of those here and online who would like to read these papers, now is your opportunity to click on the links that we are going to present and download the research in more detail. So we began this collaboration among the 8 different research institutions, a number of universities, including Melbourne, Adelaide, and here at ANU, along with some additional contributions from the Environment Defender's Office and from CSIRO. We began this 2 years ago to explore whether the risks to river inflows in the Murray Darling-Basin have changed since they were identified initially by CSIRO in 2006. So you might recall that in the early part of this century we were moving into the millennium drought. There was great alarm at falling river flows. And one of the pieces of work that was commissioned by the then federal government was to ask CSIRO to say, beyond the immediate withdrawal, point source withdrawal of water, what are the risks that might diminish the inflows into the rivers? So CSIRO identified these 6 risks: climate change, changes in stream flow due to changes in forest cover, groundwater extraction, irrigation water management, more efficient use, reducing return flows to rivers, expansion of farm dams, and forest regrowth after bushfires. After those were identified in the legal reforms that occurred with the Water Act in 2008 and again the Murray Darling-Basin Plan in 2012, the governments realised that they actually had to monitor and consider regulating these risks. And so there are very explicit requirements in those pieces of legislation to do so. And indeed, the Murray Darling-Basin Authority commissioned a whole series of sort of grey literature consultants' reports to further explore those risks. Unfortunately, many of those reports no longer appear to be publicly available. Hopefully that can be corrected. In the last 15 years, we were keen to see whether new risks had emerged, whether the scale of some risks had diminished, and whether there were changing approaches to managing those risks. And so hence our project has been intended to do a desktop review of the original risks to understand what that might mean in terms of the scheduled revisions of both the Water Act and the Murray Darling-Basin Plan. We know that inflows are changing. For example, the Murray Darling-Basin Authority reported a few years ago that inflows in the first 2 decades of this century were 39% below the historical long-term average. And so there's real questions as to whether that is short-term variability or a long-term decline. And that is the reason why we got together as 24 researchers to explore this issue in a special issue of the Australasian Journal of Water Resources that's now been published and is available here. So we had 6 groups, one looking at climate change, another looking at the impact of tree cover, a group looking at groundwater, another group looking at changes in water infrastructure and how water is managed, a big group looking at water quality, and a new group looking at how these risks are regulated. And so the format of this morning is that lead authors of each of those papers will give a short 10-minute presentation, and that will then leave us a large period of time towards the end for a discussion that Professor Daniel will moderate. These were the questions that we asked each of the thematic groups to address. What was our understanding of the risks in 2006? What is our understanding of these risks now? What are the knowledge gaps that should be addressed to best inform the revision of the Murray Darling-Basin Plan? The Water Act amendments are being debated in the Senate today, and the current proposal is to undertake that revision in 2027. We wanted to explore what policy options we have now to better manage these risks, and what further research is needed to better quantify and respond to these risks. So these are the presenters who will present today. I believe on water quality, James Latimer is filling in for Sarah Beavis, who is ill, and Luke Mosley, who has had to return to Adelaide. So James, thank you for doing that. And with that, I might conclude the introduction and segue into my new visage as Dr. Jason Alexandra. Jason led the assessment of climate change as a risk to the water resources in the Murray Darling-Basin. However, he is gallivanting around the world and is unable to be here to present that work, and so I will do my very best to convey his key messages. So Jason has pointed out that climate change is a very significant risk to the future water availability in the basin, one that was recognised in law in Section 22 of the Water Act that directs the Murray Darling-Basin Authority and other agencies to assess and ensure that there are strategic responses to loss of water due to climate change. And in particular, the Water Act says that the authority must use the best available science in terms of managing the risk of climate change. The authority, however, in 2012 made a deliberate policy decision not to make any take any direct action to adapt to projected losses of water due to climate change. So they said in response to public submissions on the draft basin plan, there is considerable uncertainty regarding the potential effects of climate change and that more knowledge is needed to make robust water planning and policy decisions that include some quantified allowance for climate change. Until there was greater certainty, the historical climate record remains the most useful benchmark for planning purposes. In other words, climate change was kicked down the road to the next revision of the basin plan, now due in 2027. In 2006, CSIRO said climate change is the greatest yet most uncertain threat to water resources in the basin, with a potential loss of up to 40% of water flows in 20 years. So the 20-year timeframe CSIRO is referring to is around 2030, which isn't that far away. CSIRO in particular, but other researchers have undertaken extensive modelling projections of likely water losses. They've come up with some very scary graphics illustrating, the current situation in blue there on the right, and potential reduced water availability on the left, to signal to decision makers that this is a very serious problem that should be addressed. There have been a great big long shopping list that Jason has catalogued here of these projections, and those projections are very similar in terms of their conclusions, suggesting that in particular in the southern basin there is a high likelihood of significant reduction in water inflows, a much more ambiguous story for the northern basin. And all of those projections have a fairly wide degree of error margin or range of projections, but the trends that they suggest are fairly consistent. And again, just emphasising some of the most recent work by Francis Chu and others at CSIRO, suggesting an overall reduction of a 20% decline in stream flow by 2047. Of course, these are average stream flows, these numbers. We would expect that with annual variability, that things like variability in flood and drought impacts might be even more severe on top of that. One of the key issues that Jason points to is the great amplification that decreases in runoff result in significantly amplified reduces of water inflows into rivers, as illustrated in this particular diagram. So even relatively small reductions in rainfall might have big impacts. Oh, no, go back. What Jason, I think, concludes is that adaptive allocation regimes for water need to be seriously considered. To date, political leaders and the Murray Darling-Basin Authority have argued that Australia's water allocation regime, whereby water entitlement holders have the actual volume of water that they can take in any one year adjusted in proportion to the water that is available, that adjustment mechanism is no longer appropriate to deal with climate change. And they suggest, and Jason suggests that for a number of reasons. One is that it doesn't account for the difference in planned water that's allocated to keep rivers flowing for the environment versus the water entitlements. That while the water entitlements might be adjusted down, many of the state water allocation regimes in drier years take a much higher proportion of all the available water, which means that the environment and related values would lose out in a drying climate. And so that needs to be adjusted. Another thing that Jason points out is that there are particular thresholds of water availability needed to sustain particular ecological assets and particular socio-economic assets. For example, drinking water for towns, or indeed a critical mass of agricultural production needed to sustain particular food processing facilities. And that if we simply automatically, proportionally adjust down the water entitlements, progressively those thresholds will not be met and a number of those values would be lost. That loss of values might not be those that are prioritised most highly by Australians. And so I think Jason here is arguing for a much more deliberative process, a triage process, if you like, of identifying those things that we value most and ensuring that limited water is directed to them. Jason talks about the next version of the Basin Plan, considering the use of ratios and formulas as an alternative to using long-term averages. He points out that the Water Act is quite flexible in terms of how these limits to take can be calculated, and that there is value in adjusting down water entitlement regimes progressively as the climate changes, rather than the governance model that has been established with this first Basin Plan of there being a decision point only once every 10 or more years. The problem with adjusting those water allocations every 10 years is that becomes very politically difficult, as we're experiencing this month in the current debate in the Senate, whereas if there was an annual adjustment, it is signalling to all water users year by year the need to adjust to the available water. And so Jason is arguing for frequent reassessment of the total resource pool and subsidiary targets and investigating alternative allocation frameworks. Now, some of these aren't new ideas. They were actually foreshadowed in the Murray Darling-Basin Authority's 2010 Guide to the Basin Plan. Dare I mention its name? And they will need to be considered again. With one last point, the other thing that Jason I think is arguing here is that the quantitative projections of water availability are unlikely to ever be as precise as the authority implied they needed to be to make management decisions in 2012. And I think that one common theme that I certainly have got from this research is the need for us to start making decisions under uncertainty, to recognise that there will be a range of projections and to find smarter ways of making good governance decisions. With that, I hope I've done justice to Jason's work. He has provided a lovely list of references to refer to, and he's made some useful acknowledgements here, which will be in the PDF that is available on the Institute for Water Futures website in due course. With that now brings me to introduce the second of our 6 thematic presentations. My great pleasure to introduce my Fenner School colleague, Dr. Andrew Ross, who has devoted the most recent years of his long and illustrious career, formerly from the Australian Public Service, but now focused on groundwater governance. Andrew, thank you.
Okay, so I'd like to start really by acknowledging my co-authors here. This is a joint product by myself and Ray Evans, an eminent hydrogeologist, and also Rebecca Nelson, who's an eminent governance specialist, and they had a huge input into this paper. So why is groundwater so important? And here we have an illustration of what happens in dry years. In the dry times, groundwater is the main reliable source of water. Groundwater is always providing the most secure source, and by far the most of our freshwater resources is underground. So it is important to understand how important it is in a strategic sense, and in dry times, to understand or better understand what the impacts are of the rush to groundwater pumping that occurs at these times. Just a brief introduction here to groundwater in the Murray Darling-Basin. So it's the key strategic resource, as I've already mentioned, in a key resource in water resource and storage, and it takes up 11 to 30% of our annual water supply, and in dry times it's a lot more than that. I wanted to make also a distinction between 2 different areas in the basin. Down the center of the basin, on the right-hand side of this screen, you can see the big alluvial resources on which most of our irrigation is based, and a lot of other groundwater resources around the periphery, the fractured rock and tertiary limestone are also large, but mostly lower productivity or saline, but there is some scope for development of those resources, whereas the alluvials are all fully exploited. I want to now move to just a quick overview of the development of the risk management of groundwater in the period that Jamie talked about, from 2006, when we had the original CSIRO studies, to the current, through the Basin Plan, to the current consideration that we've been making. In 2006, groundwater was considered as a risk to the surface water resource. So the main consideration was that water was draining out of surface water into groundwater, estimated to about be between 270 and 550 gigs of water. But between 2006 2012, a much more understanding of the integration of surface water and groundwater resources fortunately came into general understanding and into policy. And so the Basin Plan itself considers groundwater as an integral part of the basin groundwater resources and sets it, as illustrated on the left-hand side of this slide, in the overall risk framework for water resource management as set out into the Basin Plan. When we came to look at the 2022 situation, we found that there are 2 major areas of risk that aren't really fully taken into account. One is about uncertainties about the estimation of the groundwater sustainable development limits, and also because groundwater resources are large quite often, the effectiveness of measures to address local impacts of pumping and local governance regimes. And we also identified some risks that were emerging in the framework for water resource planning, which is really the key way where water resources are managed, especially at a more detailed level. And they are surface water, groundwater connectivity and the cross impacts of use of those resources, the effectiveness of measures to protect groundwater-dependent ecosystems, protection of groundwater quality, cumulative impacts of coal seam gas and coal mining, cultural values, and lastly, assessment and monitoring, by no means least. In this presentation, I'm not going to talk very much about the cumulative impacts of CSG or cultural values. Really, it's not possible to look at all the issues in this short time. I'm going to dive in, though, into three. I can go back. The first is the risk to groundwater resources overall, increased use and uncertainty. So here, we assessed that the Basin Plan Sustainable Development limits, considered at a catchment and basin scale, and when they were also considered with the goal of structural integrity of aquifers, these limits are unlikely to be threatened overall, but there are two major points here. First of all, a lot of uncertainty owing to increased demand for groundwater, which may occur during, because of cascading effects of synergistic risks, which Jamie is going to talk about more in the synthesis report presentation. And these include climate change, droughts, bushfires, extreme water quality events. We know that these are likely to increase, but we don't know how much and with what effects. And we don't know how much groundwater might be impacted by that. Secondly, groundwater pumping and drawdown is going to have local impacts on other groundwater and connected surface water. We need to find better ways to deal with that. Local impacts can be addressed by setting SDLs high enough to cover all the risks, but that would probably lead to an unduly restrictive regime. So we need to look at ways that we can use local measures and integrate that with higher level measures. And I pointed out here that you can use buffer zones around groundwater and connected ecosystems, but they tend to usually delay rather than prevent large-scale impacts, whereas triggered pumping limits could be quite effective, but they also, it's quite a problem to estimate the trigger value, and it's a costly sort of process to implement. Next, I want to consider groundwater surface water connectivity. And here we came to the view that really the basin plan isn't doing enough there, that the acceptable level of hydrological connectivity isn't defined in the plan, and that's because the Commonwealth and states haven't been able to come to an agreement about that. Another problem that we have is that water resource planning periods are, 10 years, but actually the impact of pumping on groundwater resources is very often longer than that, except that after long periods of time, then big effects can emerge in connected ecosystems. And overseas, we've had events that I can think of where entire wetlands have disappeared unexpectedly. For example, there was one in Spain that caused some major conflict between Spain and the European Union, because that was protected at the European level. Groundwater plans generally consider connectivity, but unfortunately surface water plans mostly do not. And there's a lack of measures in even the latest version of the water resources plans to deal with the local impacts of surface water on groundwater, that these impacts are generally being managed from the groundwater side. Ways forward then, what can we do? First of all, a common framework and indicators for impacts of connectivity. You know, it would be very good now to engage in a period of discussion in the Basin Plan and also engagement between the Commonwealth and states to firm that up. It's been difficult in the past. It's not likely to be easy in the future. So another thing that can be done is to agree an assessment timeframe to be applied to the estimation of water balances. And I mean a fully integrated water balance, including groundwater and ET. And to look also at the long-term risk to condition of connected water resources and ecosystems, and the opportunities to use some innovative measures, such as water banking and managed aquifer recharge. And finally, you know, we need to improve our accounting, monitoring, and modeling together with the use of these longer time periods. I know that I'm running short of time, so I'm not going to talk very much about GDEs. But, you know, I want to acknowledge that there's been a lot of development, good development in the assessment of GDEs. Where we're a bit short, however, is knowledge about the ecological water requirements of GDEs and their dependence on groundwater, and also the uncertainty about impacts on GDEs of reduced water availability and cumulative impact of coal and coal seam gas mining. Just very briefly to talk about water quality. On the left-hand side, you can see the major risks for groundwater quality. National water quality guidelines deal quite well with drinking water, and we have quite good programs to deal with salinity, but actually there is a problem with the long-term sustainability of salt interception. We need to develop some new initiatives. On the other risks to groundwater, there's a shortage of information, so we really need to develop better monitoring and engage industry into that process. Finally, to just give a fairly truncated and a few key points to think about on the knowledge gaps and policy options. So the major things I would emphasize here is groundwater surface water connectivity and cross impacts, especially during extreme events, and also the definition of threshold water requirements and improved levels of protection for GDEs. Turning to the policy, reviewing groundwater LCLs, taking account of impacts on GDEs and the impacts of and responses to climate change and assessment of alternative sources of supply during droughts and extreme events. And I've mentioned before, long-term planning targets, actions, and time horizons. Common framework and indicators for impacts of connectivity. And finally, last but not least, improved monitoring risk evaluation. Thanks very much.
Andrew, thank you. We haven't had an opportunity just to test the IT system with Patrick, who is presenting online from Melbourne. So we're just going to skip Patrick for the moment, invite Professor John Williams to present next, and we'll come back to Patrick after our morning tea. So I'll just briefly skip through Patrick's presentation. No, sorry, my apologies. John, can we move to James? James, do you mind jumping in now? So our fourth thematic assessment, and one where perhaps there was the most unique, some of the more unique changes since 2006, was consideration of water quality risks. A team led by Dr. Sarah Beavis from here at the Fenner School, and among the illustrious team is Dr. James Latimer, who heads up the laboratory work here at the Fenner School, among other many accomplishments. James, thank you.
Thank you. Yeah, so this is, we're gonna do our best with someone else's presentation here. Yeah, so I'm a co-author on this paper. One of the key questions that Jamie's highlighted at the beginning here is have the risks changed since the 2016 CSIRO report? The water quality risks really haven't been identified in that report, and so there were one or two identified, but mostly we're trying to, the crux of this paper is to introduce these water quality metrics that should be included going forward and should be assessed. So in the original report, we had salinity was included. So salinity was thought of as quite a sort of a crisis at the time, and so that was a big, that was the main water quality issue included. And algal blooms were also included, but mostly from a sediment transport mechanism and mostly around their sort of funding priorities at the time. So yeah, so the main point of our paper here is to include the water quality metrics, and so we're going through what are the water quality metrics that should be included and why are they important, and what is our current understanding of them, and what are the knowledge gaps there. So as I said, the previous report, the 2006 report, didn't really include water quality that much, and we completely acknowledge why. At the time, there was a real concern about running out of water. It was height of the millennium drought. Water quality is hard to measure. They're really complex systems. When you're trying to manage water flows, it is a large added complexity, and so we realise that having poor quality water is better than having no water. But we would really like to raise the bar on that and there's increasing quantitative evidence that something that Indigenous people have always known, and all of us can quite easily intuit that water quality and water quantity are important for a living and sustainable basin. So they're both really important if we want the basin to continue to be sustainably utilised and to be healthy and support the vast array of uses and biodiversity that it currently has. Let me work out what else have we got? Okay, yeah. So I'll go through some of the key water quality parameters that we think are of particular importance. So hypoxia and blackwater events are big, acute and often catastrophic events that happen. So they're usually driven by the accumulation of standing litter on floodplains. So we're talking about the carbon, nitrogen, phosphorus load sitting on a floodplain, and then the temperature of the water that is flooding over it. So what you get is, you get this eutrophication happening where in the warm environments, the cyanobacteria and other things eat all the tasty nutrients and use up all the oxygen in the water, and then everything else in the water column asphyxiates. And so that's mostly represented by mass fish kills. So the Menindee Lakes, where they keep happening, lots of other places. These are massive events. They are acute events, so they get a lot of publicity, and that is one of the ways in which the support is galvanised. So these large acute events, are good for bringing attention to the decline of the basin, but the slow, systemic, chronic decline in health is a much harder thing to galvanise support for. So the hypoxia and blackwater events are really big ones. They have massive, economic and environmental impacts. And similar events are then attributed to the next couple of water quality things that are included. So hypoxia is sort of the main, the effect where all the water is used, all the oxygen is used up from the water column, and all the fish and many of the other animals asphyxiate. But yes, some of the other things we're going to talk about will lead to hypoxia. So stratification is another big one, where slow or still water bodies, so either slow moving water or standing bodies of water, will stratify. So the top layer will warm up, the bottom layer will stay cool, and then the top and bottom layers will stop mixing. So then as biology happens in the lower layers, it'll consume all the oxygen, that lower layer will become anoxic, and then if there's a rapid turnover of the water, then all of the anoxic water in the bottom will come to the top, and that will become anoxic as well, and then everything up there asphyxiates as well. So these sudden mixing events can lead to big hypoxic and blackwater events, and they are something that is easily done with, or easily sort of accidentally achieved when moving water through the basin system. So that's an important thing that. Yep, algal blooms, cyanobacteria blooms. They are often the drivers of these blackwater events. They the cyanobacteria especially are very, very good at eating up the nutrients, and so they use a lot of oxygen when they do that, and they love doing that. Bushfire sediment transport, we'll hear about it more in the presentation after the morning tea, but as fires burn soils, they become more prone to debris flows, and so when you get heavy rains after fires, you get a lot of debris movement. This debris moves carbon, nitrogen, phosphorus into the waterways. They consumes all the oxygen in the water. You get more anoxic events. Acid sulfate soils and water column acidification are big parameters that haven't been looked at too much in this space, or haven't been included in this sort of policy. So there are large areas of naturally occurring acidic soils that, depending on how they are wetted and dried, will generate a lot of acid. So in the events that they are flooded or drained in sort of unexpected or in ways that are different from the historical natural cycles, they will generate more acid than they were before, which then leads to pH drops in the water, which leads to sort of metal liberation and more fish kills. Most of these things lead to fish kills. Salinity, which was a big concern at the end of the 20th century, beginning of the 21st, has so far not eventuated the crisis that was concerned. So at the moment that hasn't represented the big problem that we thought it might, but that doesn't mean it couldn't in the future. So another thing Jamie said was trying not to postpone decision making due to a lack of sort of perfect evidence. What we have a series of recommendations for. Oh yes, these pictures would have been nice. We've identified a series of knowledge gaps, and so we definitely recommend more research be done, especially around the biogeochemical processes that are happening within the basin. So a lot of these water quality parameters have been looked at as exports from the basin, but what is happening within the basin is extremely important for the life and health within the basin. And so that's really important. And so there are a few things we can do. Things like considering water quality when we're managing it, and especially the temperature of the water that we're moving. That is a big parameter. But yes, we do have a lot of information, but we require a lot more information going forward. So thank you very much.
James, thank you for doing such an excellent job of filling in. And you can see there how much some of the thinking has emerged over water quality and the need to consider it when regarding risks to shared water resources. We are going to move on to one last presentation before our morning tea break, and then after the morning tea break we'll come back to Patrick Lane presenting on forests. In the meantime, can I invite Professor John Williams to present on water infrastructure? That's the one forward. And Professor Williams, as most of you will know, is an emeritus professor at the Crawford School of Public Policy here at the Australian National University, and has had a long career at CSIRO, including as the chief at CSIRO Land and Water, and as the New South Wales Natural Resources Commissioner. John, thank you.
Well, thank you very much. There's no need for all that stuff. When you're at my age and you can see how old I look, you have to have done something. But look, what I wanted to do, there are really three things we want to say, but we want to do them inside a framework for looking at how we might see infrastructure framework. And so one of the important things from our work is that when we're looking at risks and doing the risk analysis, we think it's worthwhile when you look at infrastructure to break infrastructure up into the soft infrastructure, that is the regulation and legal and governance processes that determine the way we use water in a system. That's really, really important. Of course, we also have the natural infrastructure, which is, in a way, the part of the system that uses most of the water. And that is in the wetlands and the river systems and the groundwater systems, and the way those ecological functions work, whether they're right up through the food chain in a river to the fish. And then, of course, where most of the emphasis in the past has been in how we manage the hard infrastructure, the irrigation channeling, the irrigation fields, the pumping, extraction and the return of water. So when you have a look at that, we think that you can use that framework very helpfully, and I think it would be very helpful to take that framework forward into the next generation of the Murray Darling-Basin planning. Because we also think that we need to be able to discriminate in our risk analysis between cascading risks, risks that are interconnected risks, and risks that are systemic that may lead to the complete failure of the system. And of course, some of these papers actually pick up most of those risks. Particularly Andrew talked about the interconnected risks, the systemic risks. Jason and Jamie picked those risks up. And then of course, because things are so connected and independent, there's cascading risk. Risk on one thing ends up generating a risk that is much more difficult to control in the second system. But I think one of the big risks we do face is that we don't know where all the water is as accurately as we should, particularly in terms of the very simple international agreement of how we analyse where water is. We certainly, the non-beneficial evaporation, and this is all the green infrastructure essentially, transpiration from foliage and water storage and so on, we know that number's in that range, and that's a pretty big range. That's the non-beneficial use. But the beneficial transpiration through the crops and on-farm use, we have some ideas of that. But when it comes to the runoff and the seepage into water that can either go to non-recoverable things like saline seep, saline groundwater, and then we have water that actually goes, it's not consumed, but it's in the return flows. This was identified in the first 2008 studies, but it hasn't been really picked up in the work so far to know where our return flows are from our system of irrigation. We do know what's extracted, and we do know what's extracted from the actual groundwater. That 1832 number, you need to put that, and I say to Andrew in his work, the SDL of that number, of course, is 3350. So that there's something going wrong there in the SDLs for groundwater. I'd like to see the numbers. But so we need to get the numbers properly identified, and we don't at the moment. And one of the numbers that we need to get then, as indicated, as we've tried to say in our analyses, it could be 490, 630, and therefore when you talk about irrigation infrastructure and irrigation efficiency, if you don't know where your return flows is and you don't really know the water you're supposed to be saving and where it actually goes, then I do not know how you do the sums. And Glenn Walker has also had a look at the same thing. His numbers are somewhat smaller, but they are still significant numbers in terms of the water balance for the basin. So we need to get our head around that. That we do not have the measurements. Most of those numbers there, certainly ours were modelling and certainly Glenn's were modelling. And we don't have the measurements. We need to know a lot more about that return flow issue if you're going to manage any of the irrigation efficiencies seriously and make the adjustments in the water budget. And modelling is all we have, in short, and I don't think we know and we need to know. The other issue I want to raise is the actual establishment of farm dams and collection of water on the floodplain. These dark numbers there, I think they're blue, but I'm colourblind, but I think so. Those dark areas are where we have large dams and the high intensity. And see, pre-2004 on your left is there, and you can see the substantive increase to 2015, 2021. If you look at these numbers here, the storage capacity continues to increase right across those catchments, the Gwydir, the Namoy, the Macquarie and the Darwin. And when you have a bit of a harder look at some of the other ones in the Murrumbidgee, you see it's really substantial. Then you look at where all those farm dams are. This is some of the plotting of them from satellite and other imagery to give you some idea of the change that's happened. And there's recent papers in the journals now showing how substantial that is in terms of flow. And if the farm dams are not taken into consideration in the modelling and the capture, then the flow regimes we have in the river, the errors in the modelling is often due to we don't take this into account. And what we need to really look at the good work that Jamie and Brown and others did. They've estimated the annual volume of floodplain diversion, which is a very special case of large farms dams, their diversions, in the Northern Basin was a very large order, ranged from 632 to 926 gigalitres. Put that in terms of the total extraction from the basin, you see it's a substantial unknown. How the heck you can talk about SDLs when you don't know these numbers give me strength. This is about twice the estimated number that the Department of Planning and Environment in New South Wales are doing. Now, must add that there looks to be good progress now in trying to identify that floodplain capture in New South Wales, certainly not in Queensland, but it's got to be done. We've got a really big uncertainty in our floodplain capture. The volume of 778 is about half of all that the environmental water released annual for the entire basin in 2010. So it gives you some idea. You can't manage the basin unless you know where the water is and you know these important numbers. I know they're politically difficult, but they must be brought onto the table. And then in 2018-19, the estimator is that with the flooding, it could have been up to 1,500 gigalitres, 6 times the flow. And so these makes nonsense of the actual 70 gigalitre reduction in the SDL for the Northern Basin when you've got this level of uncertainty sitting under the carpet. Come on, guys, let's do our sums properly. So that's the bottom line. For the entire Basin, the harvest is about this number in periods of high inflows. Now, of course, it's dependent on the flooding of the floodplain, but we need to get this under control if we're at all seriously, because this work is really important to the flows that get through to the lakes at the bottom of the system. It's the northern part of the basin in the flood that does generate a lot of the flow that goes through to the mouth. And the other thing is these low flows through the Darling are critical to maintaining the oxygen status at very low stage, where the water's moving through the sand lenses in the river's basin base that's keeping the oxygen there, these low flows, and some good work showing how important this is. So the diversions of this have large costs downstream, as I said, and this good work by Malin Cooper and Zampatti need to be read and appreciated in any further going. The Minister's decision to reduce the actual, let them pump further in a couple of years ago resulted in all those low flows that were providing the oxygen aided for the shellfish and the crustaceans in the system fell away and led to a lot of the problems of fish kill. So where are we up to? So there's a lot of important things to do. We need to think about hard, soft and natural infrastructure. We need to recognise that irrigation efficiency, we need to know what that efficiency is. As one Indigenous leader has taught me, Dr. Williams, when you move water, you need to know what it was doing before you moved it. And that's a very important principle I think we need to take into the next generation of action. So we've identified some gaps and monitoring is, of course, and auditing, and I'm very pleased to see the movements forward to try and get some serious order. We need to know in data access and public accessibility. With our satellite and technologies and imagery, it's ridiculous to say that you don't know what's on the floodplain capture. Come on. So I guess there's one other issue that sits there silently under the cloth, which I think needs to be dealt with, and that is salinity. Yes, we have been able to maintain it through the salinity interception schemes, but I think we need to be looking at using green infrastructure and soft infrastructure to manage stream flow, to dilute saline flows from the landscape, and grey infrastructure, and transport those salts safely to the sea. For an irrigation system that's using high efficiency irrigation, the management of salt becomes more critical than ever. You must have a leaching fraction. If you have got a leaching fraction, you need to manage that leaching fraction all the way to the sea. And we can do that with managing the green infrastructure differently. And so thinking we can depend on these interception schemes forever is a nonsense. And we really need to get a proper salt management scheme for the basin. That this was an interim thing to get us going, avoiding of age of problem. But that salt's still remaining in the catchment, and it's also using water in a way that isn't productive in that sense. So for those two reasons alone, we need to get our act together. I think that's probably enough, and we think that the estimates of robust risk analysis can be improved. But if we really want to focus on those three things, we need to know the return flows, we need to know the floodplain capture, and we need to manage vicinity in a sustainable way. Thanks, Jamie.
John, thank you, and thank you to the presenters in this morning session for what I think has been a very thought-provoking start to our seminar. We are now going to take a break and resume again in around 20 minutes at 10 to 10.
Okay, I'm assuming then I'm good to go now. In the absence of any replies to that, I will start. Okay, so my name is Patrick Lane. I'm from the University of Melbourne, and I'm presenting on behalf of the other names on this slide. And this one's basically about the tree part of the equation. So the risks that were identified in the 2006 report were the emergence of bushfires, and recalling that we'd probably only had one of the really big fires at the time that report was being put together, and subsequently we've had several more and even larger events. So there was the fire, and then there was the mainly tax-based incentives that aim to treble Australia's plantation estate from 1 million to 3 million hectares. So when you're thinking about the areas involved in these, as everybody knows, fire is a big disturbance on very large areas very quickly, and of course, a large increase in plantation estate could have meant a significant land use change. And these, of course, are in the context of the warming and drying climate, etc. And the heart of all this is of these concerns are the connection between trees and streamflow via evapotranspiration. So the fire story, really the issue here is that fire at any severity that impacts on the canopy means that the ET processes are dampened or turned off for a while, but then it's the recovery response that has been thought to pose the risk to streamflow. And here's some maps of the basin, of fire in the basin since 2000. You can see it's confined to relatively small areas, mostly down in the southeastern part of the basin. However, where those occurrences do represent the upland forests of that part of the basin where a lot of our water from the southern basin comes from. You'll also note that there's a fire frequency thing going on here, which is seems to have really ramped up over the last couple of decades, where areas are being burnt 1, 2, 3, and even there's one little spot that's been burnt 4 times since 2003. So this disturbance is something that was fairly alarming at the time. And one of the reasons why that was that a lot of what we thought we knew about fire was informed by this curve here, which is the Kazera curve. This was developed by George Kazera in the 1980s, and it was in response to the Melbourne water catchments, which is largely dominated by mountain ash, Eucalyptus regnans, where they figured out they had a whole lot less streamflow than they should have for the amount of rainfall. And George came up with this model that explained this age-related change in ET and therefore streamflow as after disturbance. However, this has sort of cast quite a shadow over Australian forest hydrology, and indeed I still hear it now that after the Black Summer we'll only have half our water in 30 years' time, etc., etc. The fact is that most of our forests are fire tolerant, with very low mortality rates, and it's the mortality rates that would drive any big scale change in ET. So what do we know now? There's been a lot of studies in the last 15 years or so around this. Most studies have demonstrated that mostly you're either going to get a net increase in flows or a negligible impact. And there's been a lot of papers that have addressed this, both in terms of the processes involved and then also the kind of catchment water balances, etc. These flow increases can be pretty high, but usually over the first few years, then followed by a return to pre-fire condition. And the controlling variable in whether we get an increase immediately after fires when the ET is being turned off largely is how dry the soil is. There's also some recent work we've done at our group that sort of questions whether the CSIRO curve in fact is something that happens in those mountain ash and alpine ash catchments. But I remember, even though these are fairly small areas, they are where there's a lot of water, a lot of rainfall, sorry. So they're important hydrologically. We also think that fire frequency might alter species and structural mix, but that is likely to be mean a kind of more open or less dense, or even a sort of acacia forest replacing ash. So we're probably going to get less ET in those systems. Just really quickly, the reason behind this is the mixed species eucalypts, or the fire tolerant ones on the left, they recover. And there's some work from Rachel Nolan from a few years ago that sort of has the change in ET. You can see that what you get is after 5, 6, 7 years, back to normal, whatever normal is, of course, and that there's a sort of fire severity impact there. And the way this plays out in actuality is that if anybody ever looks at a fire severity map, you'll see a mosaic of high and low intensities, and that tends to balance out. On the right-hand side is what happens in the ash. It dies, and you may or may not get the CSIRO curve. And just some recent work, I'm labouring this point a little bit because it still gets talked about. Some recent work in our group is that we looked at why this would be and why it might not be the case. And it really is about regeneration densities. And what we think has happened that after the 1939 fire, we had an unusually well-stocked forest, which used more water than the forest that it replaced. And so what we think is that that's probably not even the most likely case. And I just want to stress that this connection between how many trees there are, how big they are, and the ET is the really big driver in these upland forests. And under a drying climate, you would expect regeneration rates and indeed growth rates to be dampened. The plantation impacts, the concerns were simple. If you look at this graph, bit fuzzy, but really what you see is that there's a linear relationship between plantation cover and the reduction in stream flow. So clearly a tripling of plantations would have led to a similar reduction in stream flow. However, it didn't really happen. And at the time of the 2006 report, there was only about 4.3% of the plantations established in the previous 10 years were in the basin. The ones that were established after that were largely outside the basin. So the net result was very little change since 2005 and only a pretty small coverage. We concluded that there was little additional risk from this land use. One thing that did pop up, though, is, of course, there's a push in more recent times for environmental plantings or emission reduction plantings. And we do see there's quite a few of these in the, particularly up in the sort of northwestern part of the basin. We don't really know all that much about these. We don't think it's a major water resource impact, although there could be some local impacts, but we think the densities and the kind of rainfall areas where they are is probably not going to be a big water resource issue. And of course, there's always this balance. We need more trees, more vegetation in the landscape. So we think this is reasonably benign, but we don't know all that much about it. The other one, of course, is the climate change one. We've already seen some presentation on that. The connection, of course, is via the ET responses. But we have this really somewhat confusing scenario where we're likely to have, we're under CO2 enrichment. We've got CO2 enrichment, but we've also got released rainfall, reduced rainfall and higher atmospheric demand, either temp or vapor pressure deficit. And this is tricky because there's a lot of feedbacks and offsets. So, for example, higher CO2 should result in greater water use efficiency, which means that the trees should gain carbon for a lower water loss. But those same trees might be less subject to less rainfall and therefore use a greater proportion of that rainfall. We also know there's a greening going on, so more leaf area, which means bit more rain intercepted and an increased transpiration capacity. But of course, lots of trees have physiological responses to drought where they might drop leaves, down-regulate, et cetera. And it's pretty unclear how this exactly will play out. I think it's potentially a big issue in that southern basin area in the upland forest because that's where so much water is generated from. It may well. There's a lot of scenarios where those things that I've talked about, the greater water use efficiency versus the lower rainfall, etc., kind of balance themselves out. But it's still pretty unclear. In summary, the fire impacts happily seem to have been overestimated by a lot. However, I would like to note the water quality impacts are pretty significant. And just following on from what James mentioned earlier, it's not only the nutrient story. In fact, for water resources, it's probably the fine sediment story. And those of you, I know a lot of you folks are in Canberra, or you're all in Canberra today, but you might remember that in 2003, the Cotter water supply got completely knocked out. And so that is a scenario that we may be facing in a lot of places. Plantation issue was also overestimated. Mainly because of the level of afforestation. And as I just talked about, the climate change impact is a bit tricky to work out. And I think that's where, more work is probably required. And that's it for me. Thanks.
Patrick, thank you for that excellent presentation. We've got two more presentations to go, so hold your questions for Patrick and the other presenters, and we will then have our discussion session to close the seminar. Now it's my great pleasure to introduce our final thematic speaker. Kate Chipperfield is a lawyer who prepared her work when she was working for the Environment Defender's Office on Murray Darling-Basin water governance and is now working in private practice. Kate, thanks so much for coming.
Thank you.
I better turn that on. Now it's on.
Okay, just this middle button.
No, the
Right.
arrow to the right.
Hi everyone. As Jamie mentioned, my name is Kate Chipperfield. Have also formerly worked as in-house legal counsel at a water supply authority as well, so that kind of informs part of my experience today. I'm going to be talking to you about this paper, Water Governance, the Rule of Law and Regulating Risks to the Murray-Darling-Basin. There it is there. Please download it today if you haven't already. It's co-authored by Jason Alexandra. I'm going to give you the key takeaways and conclusions right up the front. So these are as summarised as I could make them, but this is what I hope people would take away upon reading the paper. So water governance issues are a severe risk to the Murray-Darling-Basin. They can be addressed and fixed by aligning with what we call best practice water governance. We also talk about implementation of law because that's extremely important. Implementing a law requires compliance with and enforcement of it, not only from water users, but also the government itself. And if there are implementation issues, so for example, a law that requires additionality that does not materialise, we say in the paper that an analysis of best practice water governance can assist with diagnosing the causes of those implementation issues and then helping to focus the fix and the solution to them. Final key takeaway in bold, because I think it's quite important, as an identified risk under current Australian water law, our view is that water governance deficiencies must be addressed. So this is a new risk if we think about our previous conceptions of risk, and that is really the key point of the paper, that this specifically needs to be thought of as a risk and therefore addressed. So how did we get there? Here are some of the questions that guided our analysis. So we looked at whether existing regimes such as the Basin Plan and state water legislation and regulation, including the compliance and enforcement mechanisms within those regulations. Are they sufficient to achieve the lofty Water Act aims? And some of those aims I've set out here for you. So they include reversing overuse of basin resources, delivering additional water, and easier said than done, equitably sharing water between various users, including the environment. So can the existing governance framework deal with emerging risks, and what improvements would be needed so that the aims of the Water Act are achieved and that those risks to the basin are addressed? So with those guiding questions in mind, I'll take you through the method for analysis that we had in the paper. 3 things: we defined water governance, then we determined the status of governance in the basin. That's something we did by way of a literature review, and we identify barriers to, or what can otherwise be thought of as vulnerabilities to, achieving sound or better practice water governance. And then we reviewed the intersection with the rule of law. So you'll see why we did that shortly. So first thing, this is quite a packed slide, not particularly presentation friendly, but I thought it was useful to reproduce that here just because I do think it's worth reading these. These follow on from the OECD principles of water governance, of which there are 12. Slightly more slide friendly, so this is the same thing, just a little bit more succinct. So you can see that these can be grouped by themes of effectiveness, efficiency, and trust and engagement. They cover a number of things, going from financing to policy coherence to dealing with the basin at appropriate scales, stakeholder engagement, integrity and transparency, among other things. So water governance itself can be defined in a number of ways, but here is a definition that I've got on the screen for you. It can be talked about in terms of an umbrella term for a complex process that considers multi-level participation beyond the state, where decision-making includes not only public institutions, but also the private sector and society. In the paper, we essentially adopt these OECD principles because we think they're quite comprehensive, but also with a huge caveat that they can be improved and uplifted by incorporating the UN DRIP framework to advance what we call in the paper Indigenous water justice. It's a finite paper, so we didn't have enough time to go into that in enough detail, but that's kind of where we land on the framework that we use in the paper. Very high-level summary. I know it's a very huge topic, but I'm doing my best to compress it into 10 minutes. So next, looking at the status of governance in the basin at the moment and using that framework to diagnose water governance issues, we focused on a couple. So we looked at politicisation and information asymmetry, which the solution, I suppose, quite simply, is enhanced transparency as a reform priority. So some of the things that the literature review surface are set out on the screen. Probably the important thing to note about these is that it's not just egregious wrongdoing. It can really range from things that are either inadvertent or a perennial feature or difficulty in managing a large transboundary system. So I think the key takeaway from all of this is that there are some parts of it that are not necessarily a single issue that is a fault of somebody or another. It can be a variety of things that, especially when acting in concert, can produce less than ideal outcomes. So we have only focused on a couple of those things in the paper, but it would be good to have a more comprehensive review of each of those. Looking as well at the law and regulation and whether they are effective. Following on from the point about information asymmetry, my role in Environmental Defender's Office was to look at whether the law has been complied with. That exercise was really difficult in certain parts because there are some parts of the regulation that are not particularly coherent, particularly when you're looking at federal versus state and other plans. The example that we talk about in the paper is planned environmental water. My experience with that is that you need pretty significant legal expertise and also hydrological expertise to understand whether the law is being complied with and whether planned environmental water retains the same level of legal protection as it did previously, which is something that the Water Act requires. So the difficulty with that is if you can never understand the volume, for example, of planned environmental water that's protected at any given time, it's really difficult to stand up and say, hey, the law's not being complied with here, because that's something that's really hard to determine. Another thing we looked at were compliance mechanisms can sometimes be insufficient, especially where sometimes whether or not somebody's complied with a particular law can only be determined after the fact. And if that is not coupled with an adequate mechanism to then replenish any water that has been overdrawn in the following water year, sometimes we just don't get to the place where we need to be, where the Water Act is appropriately implemented. Very high level summary, but I'll take you to point 3 of our method for analysis, the rule of law. Why did we look at this? It resembles and very much overlaps with principles of good governance. To put it very briefly, it means that both the government and the public know what the law is and are ruled by it. So following on from the previous slide, in certain places it's very difficult to know what the law actually is and therefore stand up and be able to enforce it. That is vital. We need compliance and enforcement for proper implementation of law. Law must be accessible, able to be understood and translated for public participation. So really placing kind of extra demand on the government in an area like this, where we're considering a very valuable and crucial, nationally significant public resource. It kind of goes beyond other types of regimes. We need to go a little bit further here. So our paper, we talk about how a system without meaningful rules and regulations is predestined to fail to meet the challenge of engaging stakeholders or equitably sharing water among users. And we call for rigorous analysis to guide reforms to enhance and not detract from the rule of law. So this concept can be really used as a focusing prism for reform priority. The solutions that we get to, and what we call for essentially is to continue the exercise that's been started in the paper through the method that we've shown. That is looking at and deciding what is good water governance, what should we be aspiring to, and what are the barriers or vulnerabilities to achieving that, and then finding those opportunities to better align with best practice water governance. To do that, my view is that I think we need to enshrine those requirements in law so that we align to best practice water governance over time. And I have over time there because I think that's the only practical way that that's going to happen, is that we aspire to achieve this best practice water governance over time. There is a law reform section in the paper, and the key thing to highlight from that is that even though there are difficulties to do that in a transboundary system across jurisdictions, there are many legal opportunities to do that. We even talk about you might be able to do that with an amending Water Governance Act, setting out, okay, well, which things do we need to do? We need to increase capacity. We need to increase policy coherence, among other things. And in particular, probably the easiest thing I would say is to make data and information transparent. That's quite an easy legal fix and not very difficult to draft. So in conclusion, as an identified risk, water governance issues are now, due to this paper, an identified risk and as such must be addressed according to law. I do not believe it's legally available to a minister to sign off on a basin plan or otherwise until water governance risk is addressed. So that's my summary of quite an enormous paper. If you'd like a 3-page summary, I suggest reading the submission I put to the Productivity Commission for the implementation review, which is the 3-pager version. So thank you.
Kate, thank you. I'm sure the Minister is delighted now that she will have to consider governance before signing off on a revised basin management plan. While you were talking, I was just advised that Senator Pocock has just agreed to support the government's Water Act Amendment Bill in the Senate, which was the final vote the government needed to get the Water Act amendments through, presumably in the next 48 hours or so. And so that means, among other things, that the timeline for revising the current basin plan has been extended to 2027 and is required to take into account a few other things. It falls to me to undertake some sort of overview and suggest some conclusions from this body of work from the 24 researchers and the thematic papers. This overview paper, including its its supplementary material can be downloaded from the journal here. I'd like to, in particular, thank the 24 researchers who've contributed to this group of work, because we didn't receive any funding to do this. This was all researchers squeezing the research into their existing busy schedules. And I think that this is a very important service that the research community is providing to Australians to assist in better water governance. A common theme in the presentations that you've heard is the need for considering water governance in a systematic process, applying frameworks and not seeking magic bullet solutions in one element of the system without considering the implications for other elements. And so as examples, Andrew Ross presented a framework for looking at where water governance sits in the system. John Williams presented a 3 infrastructures framework and a water balance model also to think about how this should be done. And indeed, Kate has talked about the need for a systematic governance framework. Here is another framework that I'm putting forward here. This is Matt LeBlanc's and colleagues' water balance model for the Murray Darling-Basin, showing that there's a large volume of water and precipitation and evapotranspiration and a very small outflow of blue water to the sea. And my attempt here with colleagues to identify how these risks to shared water might influence that balance. And what I think it shows is that very small changes in some elements of these risks, for example, in terms of climate change, could have very large knock-on effects in terms of the amount of blue water that's available in the system if they're not well managed. What we are seeing in the Murray-Darling Basin is some significant climatic and hydrological variability and change. I started this session this morning by presenting the authority's statement that the historical record of average inflows was the best basis for governance decision making. And that basin plan was adopted here in 2012. And of course, recently the authority reported that in the first 2 decades of this century, inflows had fallen by 39%. So we've got a basin plan based on 100% water availability that is working in an environment where there might only be around 60% water availability. Clearly that's not a very successful way of sustainably managing water resources. This is a different assessment by my colleagues at the Wentworth Group of Concerned Scientists. This was undertaken by our hydrological modellers who consulted with the Murray-Darling-Basin authorities modellers to get agreement that this was an appropriate method. And what we did was classify at a number of river gauging locations the amount of water that had flown down the river in the first 7 years of the basin plan operations. So the different years were categorised into wet, medium and dry flow scenarios to take out most of the influence of climate change variability and change. And what this shows is that far less water, for example, on the River Murray, flowed into South Australia than was projected by the government management models. Now, this Wentworth Group work didn't identify the reason for that, but there are a great number of reasons why there might be less water flowing into South Australia than the government models project. It could be that the government models are not accurate, and the government modelling hasn't been particularly transparent, and there hasn't been regular updating of those models. It could be that there are changes in the way the catchments are behaving, and there's research, for example, from the University of Melbourne suggesting that many of the catchments in northern Victoria had not recovered hydrologically from the millennium drought. And it could be that there are changes that people are making to the catchments, for example, expanding water capture on farm that are diminishing river inflows. The point of this is that there are significant risks to water availability that need to be better known and managed. Now, there will never be quantitatively precise information, and there will always be some margins for error, but I would suggest that a 22% difference between what the government models think they're managing versus the actual volume of water in the river system is an unacceptably high level of error and requires action. The Water Act and the Basin Plan are very explicit in requiring the governments to identify and manage risks. This is the particular regulation in the Basin Plan, and you can see that it is quite comprehensive in terms of requiring management of things like risks from groundwater management and potential interception activities. We undertook this work as a group of researchers to try and identify these 5 key questions as I introduced this session with. And if I go back, here are some of our key findings. Firstly, that the risks have changed and will continue to change. That some risks, a few risks were overestimated, for example, in plantation forestry. Other risks have proven greater than projected, such as floodplain harvesting. And that the risks to groundwater and water quality conceptually now are much better understood if poorly assessed so that they can be managed. Water availability in the southern basin is now clearly diminishing with climate change and needs to be actively managed. And we would say that the governments can't punt this issue down the road again when the Basin Plan is reviewed. Now we all have a responsibility to make decisions under uncertainty. As I'm about to outline, these risks interact, and that wasn't considered in 2006, and they might be positively or negatively interacting. Risks to water quantity and quality remain as high as estimated in 2006, and this affects a very significant volume of water that may dramatically change what we as a society can conserve in terms of the environment or support in terms of social and economic activities in the future. And so there is an obligation on governments to manage them. We do say that monitoring is inadequate, but I think none of us in the group of 24 authors would say that research should come before more governance action. There is a need to invest in some more research in the key knowledge gaps that we've identified, but there is enough scientific knowledge now for governments to start making sensible policy decisions to minimise or manage those risks. So this is our summary of the risks that we identified in this review in 2022 and our confidence in the data that's available for those risks. And you can see that they vary. The risks interact, and that wasn't considered explicitly in 2006. As an example, a changing climate has knock-on effects in a number of ways. It might increase demand for groundwater use, for instance, and thereby impact on aquifers and there might be more surface water recharge of aquifers, diminishing surface water availability. As Patrick outlined, there might be impacts in terms of how vegetation grows and so on. So this interaction needs to be understood. Importantly, in terms of climate change, a lot of the current work has looked at the direct impact on climate change on water availability. The assessments in the water space have not looked at how society responds to climate change and whether those adaptations have positive or negative impacts on water availability. So, for example, if the federal government's proposed nature repair market is legislated and that's linked into greater tree planting for carbon sequestration, a negative consequence of that is that tree planting in medium rainfall zones would diminish runoff into rivers. Those sorts of interactions have not been explicitly managed. In this table, we have attempted to assess how the different risks interact and classified them as high, medium, or low. And we suggest that a further evolved assessment like this will be needed by the governments in reviewing the basin plan in terms of attempting to decide which of these risks are of such significance that they require a greater investment in data collection, assessment, regulation and enforcement. This being the university, we got very carried away with this lovely influence diagram showing how these risks interact with each other as a way of identifying particular points in which interventions might result in different outcomes. And so, for example, influencing floodplain harvesting or the number and capacity of farm dams, might be one strategic point of regulation that would change outcomes. The federal government that was elected last year was elected on a policy of revising the National Water Initiative and re-establishing a National Water Commission. The current National Water Initiative has these clauses about how the cost of risks should be assigned. I have never understood how this would actually be applied in practice. You can see here that in the year 2023, water entitlement holders would supposedly wear the risk of changes in the climate, improvements in knowledge, and changes in comprehensive water plans. In practice, most of the governments have promised water entitlement holders that they would not change the reliability of yields of their entitlements. And then you've got this clause which says that it's the governments that bear the risk of reduction arising from changes in government policy. So if the government changes the policy to manage the risk of climate change and changes the water allocation plans, I'm unclear from this who actually wears the risk. And this is clearly an area where improved governance would be of assistance. What is clear, I think, is that the current basin plan, to my mind, is the magic pudding plan, the well-known children's book of a pie that regenerates every time a slice is taken out. And the current basin plan says that if we simply do some more water efficiency, then we can have all of our ecosystem assets and we can sustain all of the socioeconomic uses of the water. I think that that's now unrealistic, thinking about the amount of water that will be lost to these risks. And I think that means there needs to be a change of mindset as we move into the next basin plan, and the next basin plan needs to be more of a triage plan that accepts environmental and socioeconomic assets will be lost. There are all of these upcoming decision points in which that could occur. So to conclude, improved measurement and modelling is needed. However, we cannot afford to delay risk management decisions awaiting quantitative precision. Proportional annual water entitlement reductions are not enough to manage scarcity. We do need to be, as a society, deliberative about which of our priority environmental assets and socioeconomic assets we allocate water to first. Those allocation assignments are already set out in state water law. For example, New South Wales purports to supply water first to town drinking water supplies, but in practice it hasn't done that in recent droughts where towns like Wilcannia have ended up with no water. We need much better integrated management of groundwater and surface water, as Andrew and team have so eloquently outlined. We need to think through adaptation pathways to decide how to conserve flow-dependent ecosystems. There won't be enough water going forward to conserve everything, and as a society we'll need to make hard choices about what can be conserved under changing water supply. Water allocation between consumptive uses and the environment needs to be decided, a value judgment, transparently by articulating values and priorities. The transformational options for livelihoods and well-being of communities are needed. The narrow focus at the moment of only thinking about that community transformation in the context of water misses opportunities to integrate with other sectors. So, for example, the Victorian and New South Wales riverina coincide with state government renewable energy zones, and there's enormous potential for transformations like agri-solar developments that haven't been acted on. And then finally, these points should be central to consideration in the revision of the Water Act and Basin Plan. With that, thank you. I will hand back to Professor Daniel, who will mediate the panel discussion.
Wonderful. Thank you so much to all of our speakers for those eloquent and very concise presentations. I know it's very difficult to get the complexity of information that's in the papers condensed into 10 minutes for all of our audience members. We are going to open up to the audience in a little while, but what I would like to do first is just to maybe prompt a little bit of discussion, because I think to hear what's in those papers is quite different for all of our authors, and I would be interested in hearing your reflections on some of the key terms and overlaps. Just from what I'd seen and heard across the system, we talked a lot about compound risks. We talked about a whole lot of other ways that they interconnect. We talked about cumulative impacts, connectivity, a lot about uncertainty, decision-making under uncertainty, a lot about questions of integration, about a range of different frameworks. Jamie mentioned a number of things about frameworks. And these questions about triage and maybe what could be lost, but also what could be gained. And so I would be interested in each of your reflections on maybe one key takeaway that each of you have had as to how we could link these things up, and what is a potential opportunity of, say, a no regrets or a low regrets option for these review periods. So if I can start, who would like to start? I'm going to open up to those who are feeling open to that question. John.
Well, I suspect to me the most important thing is going forward is to know where the water is and how it's being used, and we need that audit very, very importantly. We need to know what we're doing with our water use efficiency exercises, where is the return flows, how the interconnection is between the groundwater and the surface water. Our flooding patterns are very important to recharge in many of the alluvium aquifers in the systems, particularly in the Lachlan and Murrumbidgee systems. We need to get that right. And one of the things is we've really got to look at the northern and other parts of the basin, the floodplain capture. So we need to know we can't talk about SDLs seriously for groundwater when we know that we're taking out around 1,300 or 1,800 gigalitres, yet we know the SDL's 33,400 or something. So there's some stuff there that we've really got to get back to the basic science of. One of the important things is the SDLs for water for environmental outcomes. It's fine to have the water, and we must have sufficient, but we must allow it and focus on removing the constraints to it actually operating the ecological functions of the floodplain generally. It must be able to return to the floodplain, and then must be able to return to the river, and the food chains and the whole ecological functions that need to take place need to be prevail. At the moment, you can have water and you just flow it down a channel. That's not going to help the environment very much at all. And that's been pretty much where our thinking to this time is. That issue of managing the constraints, allowing the system to flood efficiently and using that water to provide ecological function has got to be put back central on the table, to my mind.
Great. Thank you so much, John. You've picked up very much on that question around the groundwater, the accounts and things. I might go to Andrew next, because you picked up very much on that. What do you think are some no or low regrets options here for reforming this round?
Yeah, John and I have worked quite a lot together, and he's covered most of the things I would want to say. One point I would pick up out of all that agenda is the effects of surface water use on groundwater, where I do think, especially when I look at the latest version of the water resource plans, is that there's much more emphasis being put onto what groundwater does to surface water, and almost nothing on what surface water extraction does to groundwater. And I think this could be very important in the future because, for example, all this floodplain harvesting is taking away from our groundwater resources. At the same time, in droughts, we're increasing our pumping massively. What's happening, and what's going to be the long-term effects of that kind of strategy if we go on? So I think that's important on the physical side. Also, I'd just like to say something about governance, because that's one of my passions. I think there's a big issue in governance that we have fairly strong policy frameworks at the top. The Water Act and the Basin Plan are, quite detailed, well-constructed documents. But there's a gap between that level of, what should we say, law and policy, and what we can do on the ground. Because on the ground, we've got lots of communities having to deal with all kinds of crises and develop solutions locally. And there's this disconnect. A lot of local communities feel that that top level policy doesn't mean anything to them, and they don't necessarily subscribe to it or feel, stakeholders in it. So there's a big question to me about what sort of mechanism that we can use to bring people together in that space between the high level and the low level, and some of the things, you can, starting at the top is, national visioning is one strategy. On the research policy side, we've got cooperative research centres, quite a good mechanism. For example, in the One Basin Research, CRC, that I've just joined, there's a real attempt there to connect researchers, policy people, and stakeholders on the ground. So it's a good model. We have to see how that works. Also, I would say visioning at the local level and how we can engage people from the higher levels into those sorts of visioning. Policy evaluation is another one. And I think something that I haven't thought through very much myself, but the role of the market. So we've tried to use market as a governance mechanism. Can we bring that, how can we bring that more into the picture?
Great, thank you so much, Andrew. And I think, again, this we're seeing some very natural linkages here. Kate had talked quite a bit about, what would it be to have, say, a water governance framework. You've talked about what's going on elsewhere, Andrew. Some of the other areas around Australia, even as Jamie mentioned, are looking at climate risk. So we have other departments who are looking at climate risk frameworks. There will be sort of the community-led evaluation of risks and nationally-led evaluation of risk. Kate, with the kind of proposals that you're thinking about in this reform cycle, how do you see those things being able to be joined up, at least at a kind of minimal level, so that they start to function?
Great question. There is going to be a lot more coordination across states, federal and in general. Particularly as well, I think there's a lot of opportunity from the Australian Law Reform Commission perhaps to realise and to assist with what is my key finding from doing this work is that a lot of legal review probably should be happening in order to make sure that the existing laws that we have can be implemented. I think there's a lot of benefit to be had where you have more lawyers looking at this. I've found that to be really useful in highlighting, okay, well, there's a lot of scope for improvement here, including, for example, in relation to data and information and transparency. Kind of the perspective I have is looking at it from a point of view of that civil vigilance arm, which is itself a type of governance. And if you can enhance that, not only are you enhancing cross collaboration between various entities, parties, departments, and interested parties generally, but you're also allowing that other aspect of governance to flourish as well. So I know I highlighted a lot of issues, but I am quite positive that there is a lot of scope for change and reform, and I would just highlight that I think if we have more lawyers helping with this process, there are a lot of opportunities there.
Excellent. Thank you so much, Kate. And one of the areas in the governance frameworks that I think was highlighted as a risk that was only partially, a smaller risk that was taken into account last time, they're looking at the salinity and looking at some of the other water quality risks. That seems to be one category of risk that maybe the governance frameworks haven't been looking at in quite as holistic manner, and you talk about civil action and people who are bringing these things to the fore. Over recent months and years, we've obviously seen quite a lot of community action around different water quality risks. So James, do you see, what kind of things do you see could be done relatively easily in this round of reforms that might be helpful for pushing this effective management of risk forward?
Yeah, I think there are a range of things that could be done, ranging from relatively straightforward to implement and all the way to fundamental shifts in the way the water is allocated. Most of the water quality issues that I've talked about are exacerbated by reduced environmental flows. By allocating more water to the environment or having minimum flow levels in the water bodies, you would mitigate a lot of these problems. That is obviously a very difficult thing to implement. There is a finite amount of water there, and so as Jamie was saying, you need to make choices around what you're gonna allocate water to. Whether you're allocating it away from irrigation, or whether you're allocating it away from drinking water, which I don't think anyone should be advocating for, but they might be. So some of those things are very difficult. Some of the easier things to implement might be taking into account water temperature when you move it around. That can have a massive impact. So things like when you extract water from one dam and send it down to the next dam, often you're pulling colder water from a higher dam and putting it into a lower dam that is warmer. And so then the colder water will run along the bottom of the new reservoir until it hits the next dam wall and then come up and cause a rapid destratification event, and you'll get hypoxic events and lots of fish kills and things like that. So that's a type of event where it wouldn't be too hard to avoid that scenario by choosing when to move that water such that it's a similar temperature to the destination, or moving it in a different way in smaller quantities. So things like that could be a thing. And I think just having to consider water quality is a big step forward when you move water and when you allocate water.
Great, thanks so much, James. So some really clear and quite relatively simple, sounds simple, sure in practice slightly more challenging, but really clear ways forward. Jamie, you talked a lot about decision-making under uncertainty, and I also note that we don't have a couple of our other presenters here with us, so talking about the decisions under uncertainty for things like bushfires and soil and others. Where do you see are the real opportunities here, now having heard all the rest of these presentations for action?
What struck me is the extent to which the decision-making in the water space has been very narrowly siloed in the water space. Socioeconomic outcomes and enabling a transition. In October last year, my other research job is as an irrigation developer in Africa, and we brought our African partners over to look at the Australian irrigation sector. And so we went to Griffith and Leeton, major irrigation towns on the Murrumbidgee River. And what struck me was Griffith was the town in which the bonfire of the government guide to the Basin Plan was held in 2010. Griffith is thriving. It's got more jobs, greater value of agricultural produce than it ever had before 2012, with less water. And why is it thriving? Well, it's thriving because there's some fantastic entrepreneurs there who are doing some really innovative things in terms of taking waste products and adding value, turning things like cotton waste into livestock feed. Using water to grow in aquaculture production, and then using the highly nutrient-enriched Murray cod pond water to add to fertilise the crops. A whole series of really innovative measures. Now, when it comes to the water reforms, we've spent $13 billion. Billions of dollars have gone into subsidising irrigation infrastructure. Only $200 million was available for regional communities to think about transitions, things that would make a big difference. And I think there's a whole lot of low-hanging fruit in terms of adaptations that would enable us to deal with these risks to water. Things like managed aquifer recharge to provide reliable and clean drinking water for towns that have missed out. Things like netting many of the permanent crops that enable reduce evapotranspiration, healthier crops, reduce the take of produce by wildlife, and adapt to a drier future. And so, picking up on Kate's point, how can we empower regional communities more to take the sorts of central targets and limits that will be required in terms of less water being available, but ensure that these regional communities have the opportunity and responsibility to do locally appropriate adaptation that draws on their knowledge.
And I think there are some really helpful and very practical ways forward, including just working with our communities. And we're all the people who know our own communities best and what we might be able to do, what's feasible, what's not. And I think having the opportunity to do that, to think through, to have this new scientific information, these updated risks, to understand what they are, and then to put those in the local context, and also to coordinate across those to make sure we take into account those cumulative impacts or the other systems of governance is a really important thing. I think now we've got about half an hour left. We will open up to the floor for questions. I'm also going to ask my colleagues who are online if there were questions from our friends online. So do I have any questions for the moment from the floor? Or from online? Yes. And please, if you're able to identify yourself, that would be great.
All right. My name is Michael Harrison. I'm from Icon Water.
Hang on, we'll just get you a microphone so that everyone online can hear you.
Thank you.
Thanks so much.
My name's Michael Harrison from Icon Water, so we local water utility. We have a lot of obligations around fish and reducing cold water pollution and e-flows and such. And I guess my question was for you, James, around water quality and the changes of the risk that's occurred over the last decade, and whether perhaps maybe just fish kills or biological indicators are a better measure of change than, say, some of those parameters around water quality. So
yeah, I think they're great questions. So I think what we measure and how we measure and where we measure are functions of how much money we're willing to throw at the problem. So indicator species like fish or crustaceans or small animals, they are very cost-effective ways of assessing the sort of general health. So if species A is dying out, then it's we've reduced the water quality to about this level. If species C is dying out, we've reduced it down to about that level. So they are they're good catch-all measurements, and so I think they're good things to measure. I think it'd be nice to measure the quality with a metric other than deaths. But that's sort of I think that's a general function of how much we're able to apply to it. From a risk standpoint, an increasing risk standpoint, I think Icon Water, in the Lower Molonglo Water Quality Control Centre especially, but water quality control centres in general are left holding the bag with poor water governance, poor chemical regulation. And so, the sewage treatment plants are legislatively responsible for their discharge, but they are technically unable to treat a bunch of the things that come into their system. So Canberra is a good example because the Water Quality Control Centre discharges inland, and so in some years it represents 100% of the flows of the Cotter. So whatever is coming out of the plant is what's going down the Cotter and what's going into the Murrumbidgee, and they are able to treat for a certain list of things, and they do a great job. But there's all sorts of stuff coming out of Canberra's sewage. There's all sorts of emergent pollutants. There's all sorts of hydrocarbons and PCPs and all sorts of things that can't be treated, and that now becomes part of the water flow going downstream. And so, I think there's sort of a general legislative issue there, and so there are things that are worse than nitrogen and phosphorus pollution, but I think it's a very complex problem, and I think that a lot of it is not well characterised in a way that is presentable to policymakers. I think there is a lot of good information there, maybe not specifically for Australian context. There's a lot of data from Europe and from North America that would be slightly different in our context, and so is hard to push against people that don't want to see change. But that's quite a bit rambly. So yes.
Thanks so much, James. Jamie.
Great to have you here from Icon Water. I'm on the Icon Water Advisory Committee, and I know that Icon Water is among the most transparent and accountable of the water utilities. I think the point that you raise is a broader one for the Murray Darling-Basin, and it's extraordinary, I think, that the state and federal governments haven't agreed to a standard public reporting of the water quality available in drinking waters. And so, as an example, in New South Wales, while local governments are required to test urban drinking water, they're not required to publicly report that, and it's not systematically available. And so, the community then doesn't have access to the information across the basin about what that drinking water reliability and quality is, to demand, if you like, better management from the governments. And so we've seen, the previous New South Wales and federal governments proposed to spend close to $1 billion raising one dam to supposedly supply drinking water to a series of towns. in rural New South Wales, rather than actually analysing what the precise water reliability and supply issues are, and investing probably a much smaller sum of water into things like managed aquifer recharge, recycling, water efficiency projects that would produce much better socio-economic results for far less money. I'd also note that the upper Murrumbidgee above Burrinjuck has had this bizarre status legally in management of water under the Federal Water Act and the Basin Plan, in terms of being part of the Snowy Hydro managed waters. Effectively, the upper Murrumbidgee and other headwaters have been excluded from the Basin Plan. In the agreement that I believe the government has reached with Senator Pocock today, there's a proposal to change those arrangements, and that will have hopefully important implications for water flows and quality in the Murrumbidgee system.
Thank you. Thank you very much, Jamie. Excellent question. Do we have another one? Yes, we have one from online, I believe.
So a question for the panellists from online, from Paul Burns. Which comparable river system elsewhere has had a better management system that leads to a better understanding of where the water goes?
Where the water goes. So we've got a very specific question there about other river systems. Does anyone have an example river system where they've got some innovative or interesting ways of understanding maybe that water balance or where the water goes? I can see Jamie pondering. Off you go, Jamie.
Perhaps I'll take that. I mean, water management globally is often of a very poor standard. That being the case, even if management of the Murray Darling-Basin is of a higher standard than other places, I don't think we should accept gaps and failings in that governance as being good enough. There are other river systems that are managed very tightly. There are smaller ones like the Yarra in Victoria that are being very intensively managed, and there's a lot of innovative work going on in terms of governance and restoration. There are other rivers that I've worked on around the world where I think there's some very positive and major changes happening. So Rio São João in Brazil near Rio de Janeiro, for example, really positive stuff with local governments banding together to form a consortium, and with some quirks of Brazilian law getting a fair bit of federal government money to dramatically transform the way that river system is run in terms of restoring water quality and beginning to address things like the barrier effect of dams on fish. So I do think there are some other positive examples around the world that we could learn from.
Yeah, certainly are. The US has, for example, got systems where we look about extraction. We talk about what you took out, but what you then let flow through to the system. So the return flows are clearly defined as part of a licensing arrangement for the water you have. So the person is responsible for knowing what they pass on to the next user in the system. And that's certainly true in the Italian and Dutch systems, and it's certainly true in the Midwest of USA. So yes, we probably are trying to do the very best, and it is difficult, but we really do have a highly variable climate to manage, and therefore having context of the variability and the size of these uncertainties is more important than probably anywhere else in the world.
Yeah, so I wanted to mention that in the EU, European Union, that they have an extremely highly developed regulated method of managing water quality all across the countries of the European Union. And I guess this is probably best practice for at least the strictness of the definition of standards across the world, but implementation is another matter. And you know, I've had quite a lot of discussion with colleagues from around the world about that, both Europeans and Americans and people in Australia. Really, the problems that the Europeans have are twofold. First of all, they define very strict standards for water quality in different uses, for drinking water, for other purposes, for diffuse pollution. It's very hard to implement. Many countries in the Union, particularly in the south of the Union, have had difficulties, both politically and because of resources. So these models exist, but the question is, how far do we want to go down that track? In fact, you could argue that in the Australian system, we have a mixture of regulation and community involvement. And I guess what I would say about EU, it's really worthwhile for people to look at what happens in the EU and look at what sort of challenges they face and say, well, what lessons can we learn from that and use here?
And the US, don't forget, because that's really important. I guess, I don't know, Kat, whether you can take another question.
That's all right. I was just also going to say, from the side of some of the governance, you know, often there are very interesting water laws around the world. Kate touched a lot on, you know, you can have a great law, but you also then need the compliance and the enforcement. And I wonder here whether there's anything that you wanted to talk on about that, because we've seen some great things around the world. You know, it might be about integrated management, it might be about inclusion of First Nations perspectives. The implementation is a really important part of the puzzle.
Yeah, so following on from the discussion we've just had, I will note that not every country in the world has the same fidelity to the rule of law that we do here in Australia. And the other advantage I would say we have is that while we're managing a really large system that spans like over 1 million square kilometres, we're only dealing with not so many constitutions and languages as other basins face. So I think there are some real opportunities here for collaboration. Even though there has been difficulties in a transboundary system like the one we're dealing with, there's a lot of opportunity to be world leading in this space. And I think if we're, as a country, able to engage with these issues and further the governance of the basin, a lot can be done, and we can then be an example in the world.
Kate, if I could add, Catherine, if I could add to that, and add to what Jamie and Kate have just said, I think we have a great opportunity in the basin to get a governance to work where the regional bodies have a real ownership and a say in how they manage the transition. The sorts of things Jamie pointed out is when communities can actually be resourced to manage and improve their infrastructure, it increases, and an investment in that will increase the opportunity for the community, as Griffiths demonstrates, to actually change their way forward. And therefore expenditure, as we go through this change, on infrastructure in our regional centres is critically important. And the opportunities for change will be huge. But one of the key things is that the Basin Plan at the moment has as its core the Water Resources Plan. And those water resources plans are currently not owned by community. And I think there's a great opportunity to get a governance systems where the actual water resource plan and the way we manage the water in the Guaida is different how we manage the water in the Peru, and we need to look at the experience I think we had before of catchment management authorities where they can be part and own the solutions and integrate a lot of behaviour across the local government areas. And I think we have opportunities in Australia, as Kate has said, to really look at how we can govern ourselves so much better by engagement of community and empowerment of community to find solutions to moving towards sustainable use of our river. I've seen a lot of evidence of that when I rolled as Commissioner, and I just think we don't want to lose that learning, because I think it can make an enormous difference to the ownership of the water resource plans and the ownership of the change and transformation we need, as long as we recognise we need to put investment in the communities that are under that change, investment in infrastructure and possibilities that increase the flexibility of those communities to respond. Thank you.
Great, thank you, John. All right, we have a question up the back. Yes. Is there a microphone? Thank you.
Thank you. Peter Crabb. I'm one of the oldies at the Fenner School. I want to pick up something that Jamie said, because what he was talking about, the people in Griffith, was at one end of the spectrum, so to speak. Because at the other end, you've got the people who flout the law, take what they want, and there seems to be no sanctions. They're gradually developing. But I go back to a comment made by the Episcopalian bishop that performed at the wedding of Harry and Meghan when he was interviewed by Lee Sales. His smile beamed all the way through the interview, except at one point when she asked him something along the lines of, what do you really believe is the fundamental problem that we're facing today? His face went serious and he paused and he said, unbridled selfishness. That's what I think we've got to get to that point. A similar thing was said some years earlier by the Anglican Bishop of Bendigo, Oliver Hayward, talking to farmers, irrigators in northern Victoria about salinity. And he said to them, it is wrong to let your saline drainage water go downriver to your neighbours in South Australia. He said, it is wrong, it is morally wrong. And using his religious language, it is a sin. I think we have to change the mindset. Because people in Griffith, Jamie, while you spoke, they were thinking of their community. It wasn't all going into, that's mine. And until we can get to grips with this, at the political, bureaucratic, and community levels, we've got an awful problem on our hands.
Thank you very much, Peter. Who would like to respond to that in terms of, our humans and how we work with each other, moving towards that more altruistic community perspective rather than the selfish one? Who has some perspectives on that about, can be in the law, it can be in practice, can be with these particular risks? What do we have to do there?
I think the Nobel Prize winner Elinor Ostrom's socio-ecological systems framework is a good way of thinking about how to encourage the better angels of our fellow citizens' hearts when it comes to water management. And to the extent that we can have laws and government programs that involve subsidiarity of empowering and giving local communities the opportunity and responsibility for developing these water management systems, that to a greater degree become self-enforcing, greater accountability and transparency. At the moment, many of the current governance systems in the basin are far from transparent. I mentioned the example of local governments monitoring water quality but not publicly reporting it. Another one I would point to is the way our governments are accounting for the water is a sort of single entry water accounting model where they're counting what water is being taken out and comparing it to a target. They're not then measuring what water's left in the river and does it add up to what they expect, and where there is a difference, working out why it's not what is expected, and then being able to have that transparent discussion with the community about what the reasons are for the difference, whether it's simply a modelling error, whether it's a change in the environment, whether it's somebody stealing water. The more that we can set in place those institutions in our society that aid transparency, ownership, I think the closer we'll get to a more perfect system.
Thank you. We've got John, Andrew. Yep. Sure.
Yeah, well, I've seen Peter's point is valid, but when you set up community process and engagement processes and empowering to have to deal with a problem, I've been so impressed with how communities of different value sets, and whether there's people who thinking only of themselves, when they're put together to resolve a problem as a community, my experience is that most people will rise to the very best in the human condition. There will be debate and difficulty, but when it's left to our community to resolve how best to work on a resource that all people own and value, and that's what the problem is with the current water resource plans. They're not owned and valued as this is part of me. I'm part of this community, I'm part of this catchment, and I want to aspire to the very best. I've seen that work, particularly in Namoy and other catchment management authorities, where they've been prepared to give up voluntarily entitlement to see the Narran Lake revive. And I've seen that happen, and I therefore are very strongly of the view we must get community engagement and regional engagement in this next generation of plan, where there's ownership of the water resource plans and commitment to sustainable management of our rivers.
Thank you, John. Andrew?
Yeah, look, I quite agree with you, John. I mean, I think that's a terrific point that we have lots of examples of really good work in this space where the sort of problems that Peter raised haven't happened, but on the other hand, they certainly do, and they happen globally, and they've led to different sorts of concerns. One is a lot of thinking about the human value for water and how that can be represented. And I think a very important one that's coming through, hasn't been mentioned much in our discussion, is First Nations and the way that the traditional communities all around the world, as well as in Australia, have a unique perspective here and understanding about resources and people's relationships to them. And I guess that leads me to a point to add as well to saying these nice things about our collaborative processes, but sometimes our collaborative process don't sufficiently engage some important perspectives, like the human right to water, or even the right of the river itself, as Kate and I were discussing the other day, but also, most crucially, the First Nations.
Thank you, Andrew. Kate, did you want to add anything to that one? No? All right, excellent. I think we've got time for one or two more questions. So are there any other questions from either online or the floor, or any of our panellists who want to ask other panellists questions? Yes.
Thanks all. Most of this work was being put together through 2021, early 2022, which was a somewhat problematic year for many communities due to the flooding. Part of the flooding issues coming in the water quality side of things, it's also a big impact in terms of recharge to groundwater, but it's also inundation of communities. Menindee was a good example of that, where the predicted flood height was completely wrong, and the community was caught by surprise. So that flooding side has kind of been missed in a lot of this. Any comments on the risks there? It's not really a shared water risk, but it's a water risk.
Looking at the climate change data, which Jamie presented to us, the likelihood of flooding and high risk was clearly identified as a major issue. And I think it is going to be a major issue for the adjustment in the Murray-Darling, not only from the point of view of the infrastructure that we've got, the towns and camping grounds and other infrastructure that's on floodplains, that need to be flooded to deliver ecological outcome, but actually where we've got communities at high risk with the increased likelihood of extreme events. We may not have the total volume change, the integral under the curve may not change, but by Jove, the frequency term will change. And that's what our work suggests very strongly.
I might go to James next as well. Yep.
From a quality standpoint, I think so. Floods often transport a lot of sediment, and the sediment can act as a sink for a lot of different chemicals, and so a lot of slow and prolonged pollution can build up in these sediments, and then when you get flood events, you get 50 years of prolonged pollution dumped into a town at once. And so that's where the sort of the memory of the basin, of the memory of historical pollution and of poor management long term can have sudden, very acute impacts on locations. And so that's sort of from a pollution standpoint. It'll also contain lots of nitrogen and phosphorus and all the good stuff. But yes, I think that can be a big water quality problem. Yeah.
Yeah. In terms of the sediment side, it's important to remember that sediment itself is not necessarily a contaminant. It's an important part of the system and rejuvenating the floodplain areas. The problem is when it's too much, and also what's attached to it. Yeah.
I think that's an excellent point. Yes, sediment transport is a normal process that's happening. It's when you get sort of atypical events, and so they can be when you've got lots of pollution absorbed to these particles. It can be when landscape changes have meant that sort of certain fractions of the sediment profile, the soil profile, are preferentially transported. So you're getting a lot of fines, or as the bushfire presentation was talking about, post-bushfire, you're getting a lot of very easily moved soil material. And so if you've then cleared all the vegetation between that area and the watercourse, then you're going to get a lot more ending up in the watercourse than you would otherwise have. And that's where these processes that are naturally occurring, by modifying the landscape, we are creating new outcomes that the system isn't set up for, hasn't spent millions of years adapting to, and so we're getting new outcomes that are creating a new environment that much of the landscape is not adapted to.
I think it's an interesting point when you talk about, how atypical it is, and obviously under, the climate change and the potentially increasing variability that the science suggests that we will have. We've had many of these events now. I think someone mentioned, the 2003 bushfires, but we had the 1983 bushfires. We have this knowledge now, I believe, that shows that many of these risks are repeating, and in fact we have a much better understanding now of what some of the impacts of those would be. So Jamie, considering that, that we've kind of got an idea about the uncertainties, but we also have a better understanding than we did, in 2006, where to from here?
Just briefly want to respond to Barry's question about flooding. And we talked earlier about what are some of the low or no regrets measures that we could take now to make decisions to manage some of these risks. In 2013, the state and federal governments agreed to, and the jargon in the Murray Darling-Basin is dreadful, goes by the name of constraints relaxation. And essentially what this means is reaching agreements with local communities to enable managed environmental watering events to fill up the river channel and spill out onto the floodplain. Now, Victoria and New South Wales agreed to approach 3,300 farmers to reach these agreements, essentially to purchase flood easements, and they haven't. And the government's sold this program as a dreadful impost on local communities. They're going to flood people's land, it's terrible, without actually turning around and saying, well, actually this is a really good way of managing future risks. Most farmers already know that their lower paddocks flood, and all we're doing is paying them for the right to do it once every few years, and paying to relocate anything that's in harm's way to somewhere on higher ground. And for most farmers, it's doing what they already do anyway. You wouldn't put a crop on a paddock that might be flooded. And it's about a massive investment in local communities to upgrade roads and bridges and levee banks. And if that had happened, then the floods that occurred this time last year, the government tap turners on the dams would have been able to do more dam pre-releases than they were able to, and potentially lower the height of some flood peaks. So there are practical things we know how to do, we just haven't got our act together to do it. You mentioned Menindee. I was there in May, and it's one of the most disappointing meetings I've ever had. Standing on the Weir Wall with New South Wales state government representatives, and no state government agency was able to say that they were responsible for managing the flood risk and the water quality risk at that point. The agencies all pointed their fingers at each other. They flew in from Albury, 1,000 kilometres or so away. That town, that community had one national park ranger, there's 2 fisheries officers for the entire Barker, no EPA, no Water New South Wales management staff, and yet the federal government pilot Indigenous Ranger program has funded the Indigenous Rangers, and they had 12 bright young people with uniforms and boots on the ground who could do a lot of these public good activities if only we invested in these communities. The local people at Menindee knew the behaviour of the floodwaters, knew that there was another flood channel that the state government bureaucrats in Albury and Sydney hadn't factored in, and they knew what the flood was likely to do. It was just the state government agencies weren't listening. So empowering that community governance, I think, is a really important element.
Fabulous. Thank you so much, Jamie. I believe we're almost at time. And so before I hand back to you for the final close, I just wanted to make a few closing remarks and just say thank you very much to a number of people. First of all, I wanted to thank the Institute for Water Futures for hosting this event. Part of this goes to the convening capability of the Institute for Water Futures as one of the initiatives in our national university. So to bring all of these people from across Australia, important scientific and governance work together to have these conversations and to be able to put some of this work in important places. In terms of that important place, I'd also like to thank Engineers Australia, who is the sponsor of the Australasian Journal of Water Resources, working through Taylor and Francis, for allowing us to have this special issue and also to advocate for its release to be made open for the periods of these public reviews. We really appreciate that. We know it's a complicated process, the publishing landscape, and we're really appreciative to have that free access for all of our public servants and those communities who otherwise may not be able to get access to that information. I'd also like to very much thank our guest editors for managing the process of all of the reviews and the development of this, and of course our author group. So thank you so much to everyone, and with that I will hand back to Jamie for concluding remarks.
Catherine, thank you. If I could start by thanking my 23 fellow authors of these 7 journal papers. I think that this has been really timely in updating important information that Australian society needs to make better informed decisions about how to manage the water resources of the Murray Darling-Basin and elsewhere. I want to thank you for taking the time. This was an unpaid extra role. Thank you for taking that time to do this important work, to participate in this broader program that has enabled us to publish this update and have important conversations this week with the government agencies that we held on Monday to provide the information and encouragement for them to take that up as they have the opportunities in the next few years with things like the Basin Plan review in 2027 to move us that much further towards more sustainable water management. I'd like to thank Catherine as Editor-in-Chief of the Australasian Journal of Water Resources, Engineers Australia and Taylor and Francis for supporting the special issue. Greatly appreciated. Having this in the public record and not just another grey literature report is so important. We appreciate that. Can I thank the Institute for Water Futures for sponsoring this event and all the work that you've done into recording it so it will be available publicly for those people who weren't able to join us this morning. You know, your excellent communications work. So thank you so much. And to Georgia Kamara, who helped also round up the authors on my side, and Samantha Corbett, who earlier worked on this. Thank you for participating. I hope this has provided you with the encouragement in your different roles to move towards even better, more sustainable water management in this nation of ours. Thank you.